Hi there. So this little short video clip's going to show a worked example for a dynamic programming problem that you are familiar with, the coin change problem, the minimum coin change problem, but it's going to be applied into a different context as an example. So we know the coin change problem states the following. We want to minimize the unlimited number of coins which we have available in unrestricted quantities, but in restricted denominations of D1, D2, and Dn. And we want to make change for a given amount, say C. So let's just change this problem around to a more practical kind of problem. Perhaps we have an AirTasker. An AirTasker wants to choose different jobs in a way to minimize the traveling time between those unlimited quantities of tasks which are available in restricted time spans in hours of T1, T2, and Tn, and they want to work H hours. So they want to minimize how many jobs they take to fill in their 8 hours to minimize the traveling time. So this is really similar to the coin change problem. So let's set up the structures we need to solve this in a dynamic programming way. So if we're going to use dynamic programming with an array and building the solution from the bottom up, we need to create an array structure to incrementally build up the solution from 1 to H hours. We have available, say in this example, jobs that are of length 1 hour, 3 hour, and 7 hour only, always restrictions. And so there's our DP array. So we want to start this example and say we want to just do this for 8 hours. So I'm just going to grab my pen here and annotate this example. Okay, so we want to make H equal 8 hours. So we're going to initialize our array. So it's going to have, these are the index positions for the array corresponding to the incremented hours up to H equals 8, and we might even have a 0 index as well. Okay, to initialize this array with initial values, we're going to accept the maximum possible of jobs to begin with as an initialization. So when we have 1 hour available, obviously we can only take a 1 hour job. When we have 2 hours available, we can take 2 1 hour jobs, 3 1 hour jobs, 4, 5, 6, 7, 8 1 hour jobs. This is the worst case for this AirTasker. They want to minimize the number of jobs they can take, and of course 0 for 0 hours. So let's examine how we would do this. So we've got each hour, we can examine the 3 options that we have, which happen to be 1, 3, and 7. Of course, when we're at 1 hour availability, we can only consider 1 hour jobs. So we've done that, and we've got the minimum number of jobs when 1 hour is available. Same thing when we've got 2 hours, of course, we've got the same options. So 3 and 7 are not appropriate because they're too long for the time available. So we can only consider 1. So let's go back and have a look. 1 job plus 1 more job is going to give us 2 jobs. That's all we can do. We can't do any better. So that's all we can do. So for 3 hours, let's have a look what we can do. We've got our choices 1, 3, and 7. We can go and explore those. We can go and explore the 1 option, the 1 hour option. So we can go back 1 hour and see we can add another 1 hour job to what we have in the index position 2. That makes 3. That's no change, but we've explored that option. We can go back in time 3 hours earlier and accept a 3 hour job, which is one of the options that we have. So that's much better. So we have accepted 1 job, 1 3 hour job. Of course, 7 hours does not apply for a 3 hour allocation. Again, we go to the next cell. So we're making sure we're keeping the best value possible. Again, examining our options. We have the 1 hour, so go back in time 1 hour. Can we add a 1 hour job to the one we've already taken? Yes, we can, and that's an improvement. We can then have 2 jobs here, a 3 hour job and a 1 hour job, or we could go back 3 hours back in time, back to 1 hour past, and we can accept a 3-hour job, which will also give us 2 jobs, which we already have. That's no improvement. So we've explored this option, and 7 hours is not appropriate still. Now let's see the same pattern for 5 hours. We've got those 3 options. We can go back in time 1 hour ago and accept another 1-hour job, which is much better than what we have in our initialization. So now we have 3 jobs there. Or we can go back 3 hours and accept 1 3-hour job, which gives us 2 plus 1, 3, same value, no improvement, but we've explored that. And 7 is still not appropriate. Come to 6 hours, we've still got our 3 options, 1, 3, 7. Let's go back in time, 1 hour previous, add another 1-hour job. That will go from 3 to 4 for 6 hours, which is an improvement. So we keep that. We're minimizing, remember. Or we can go back 3 hours in the past and accept another 3-hour job, which is even better, giving us an improvement of 2 jobs accepted. And of course, 7 does still not apply. Okay, we get to 7 hours. What do? We've got our 3 options again, 1, 3, and 7. Go back 1 hour in time. We have 2 jobs accepted there, accept another 1-hour job, and that's much better. We'll get 3 jobs there, which is what we want. Or we can go back 3 hours in time, back to 4 here, accept a 3-hour job to make 7 hours. That's going to make 3 jobs, no improvement there, but we've explored that option. Or we can go back 7 hours in time and accept a 7-hour job, which is much better, and we only have to accept 1 job. So we've explored that option too. Now our final 8-hour allocation, let's just try this same repeated process again. We go back in time, 1 hour previous, accept another 1-hour job. That's much better than 8. That's going to give us 2 jobs there. Or we can go back 3 hours in time to at 5 hours, accept another job. That would make 4 jobs. That's no good. So we've explored 3 hours as well. And we've explored that, and we can explore the 7-hour option. We can go back 7 hours in time to 1 and add 1 7-hour job, which will give us 2 jobs, which is exactly what we have. And now we've explored everything. So now we've explored the whole, all the possibilities for minimizing our 8 hours allocated for working on AirTasker jobs and tasks. What does this look like in the equivalent pseudocode? What have we done here that makes it the same as CoinChange problem? So basically we have run a nested for loop. We have gone from h hours equals 1 to 8. Okay. And we have then taken a task for each task available in the lengths of tasks that are available, 1, 3, and 7. What we have done is minimized what's in our DP array. So we have sought to minimize the value in our DP array at position H. We have chosen to minimize that value. We've taken the minimum of what's currently in DP H, okay, because H goes from 1 to 8 hours, with our possibility of going back in time minus the task length and adding 1 job to that. So that is the equivalent pseudocode for minimizing the jobs taken and minimizing the travel time.